This is question number 4 on QZ10 for module 13 on the cash flow based valuation. So this question is about estimating the share value using the discounted cash flow model. So we're provided with sales, NOPAT, and NOA for different years, and also for the years are divided between the horizon period and the terminal period. And then we're provided with the WACC, 13.3%, and the terminal growth rate, and shares outstanding, and net non-operating obligations, NNO. Notice here it's a negative number, which means that the firm actually has some investment in some other, probably some other firms, or in the financial market, so it's earning money instead of having the liabilities or obligations. We know that after we have done the DCF, discounted cash flow model, to get the intrinsic value of the firm, we need to subtract the NNO to get the intrinsic value of the equity. Since we are subtracting a negative number here, so eventually we need to sum up the negative number of this negative value of this NNO, which is positive $255 million. So we need to pay close attention to the rounding requirement. You can see that here it asks us to round your answer to the nearest whole number except for the discount factors. So for the discount factors, if you check that, it asks us to round to 5 decimal places, and shares outstanding. This is round to 1 decimal place, and stock price per share is to round to 2 decimal places. And so part A is to estimate the value of the share common stock using the discounted cash flow model. So the first step for any financial statement analysis is to copy the numbers into the Excel sheet, and that will facilitate the calculation. So that's what I did here. And I also put the information such as WACC, shares outstanding, and all also into the same Excel sheet, and also the terminal growth rate. So basically, we just need to fill in all these blanks here, basically all those blanks here. So starting from the increase in NOA. So increase in NOA is basically for 2012, it's the NOA of 2012 minus the NOA of 2011. So we just need to subtract or use the 1612 minus the 1333. And we do that for each of these years, and that gives us the I actually need to do that also for the terminal period. So that gives us the increase in NOA for all these years. And then we can calculate free cash flow from the firm, FCFF, which is NOPAT minus the increase in NOA. So then we just use the formula NOPAT minus the increase in NOA. And then we also do that for all these years, including the terminal period. Actually, this is the beginning year of the terminal period, right? The discount factor, this is a 1/1 plus the WACC, basically RW, right? It's the WACC, and then raised to the power of T. So T is the difference between the corresponding year and the starting year. So let's start from 2012. So this is going to be, and then we need to notice that we need to round this to the 5 decimal place. So let me put everything inside the round function, and now I can put this 1/1 plus the WACC. I do want to fix the WACC cell here because later on when I want to drag the cell to the other years, I don't want this to move. And then reach to the power of open. And then I need to, for the first year, I need to subtract the starting year, but I need to fix the starting year cell again because later on when I want to drag the cell, I don't want the starting year to change, and then I just want the corresponding year number to change, and that will give me the difference between the year I'm calculating the discount factor and the starting year. So I guess that's basically what should be the case. And then we should round this to 5 decimal places. And then since I have considered the number of decimal places, so I can now just drag the cell to the other years to get the corresponding discount factor. So present value of the horizon FCFF is simply multiplied the FCFF by the corresponding discount factor. And then don't forget, we need to round this to the nearest whole number, right? So keep 0 decimal place and then drag the cell to the other years to get a corresponding present value of the horizon FCFF. And then cumulative present value of the horizon FF is simply the sum of all these individual present values. And present value of the terminal FCFF, right? So this, again, this needs to put inside the round function. And the reason also is because the setup asks us to use the rounded answers for subsequent calculations, right? So that's why we need to use the round function in the intermediate steps. So round, and then I need to calculate the present value of the terminal FCFF. First, the FCFF at the beginning of year of the terminal period is this 928. So that's my numerator, and my denominator will be the difference between WACC and my terminal growth rate, right? But so far, this present value is in terms of the ending period of the horizon period, which means it's at 2015. But what we need is the present value in terms of the 2011. And then, so that means after we have done this present value in terms of the 2015 calculation, we need to further discount this back by open that by the difference between 2015 and the starting year 2011. So this is my present value of the terminal FCFF, and then don't forget we need to put this round to the nearest whole dollar. So total firm value basically is the sum of these two present values. And NNO is directly provided, but if we go back and check the rounding requirement, it asks us do not use negative signs with any of your answers. So that means we need to add a negative sign in front of this NNO just to convert that into positive number. And then, but we need to keep in mind this is actually negative. So when we subtract this from the total firm value to get the active value, we actually need to add up this positive 255 to get the active value. So that's what I want to do here. So the shares outstanding is also directly provided here, and that's all these numbers are in millions, right? This is in millions of dollars, and this is in millions of shares outstanding. Stock price per share hence can be directly calculated by dividing the aggregate equity value by the shares outstanding. So don't forget, we need to use the round function again to keep this to 2 decimal places, right? And shares outstanding here, we need to keep that to 1 decimal place. So we can just convert this we can just use this as a round function and to 1 decimal place. It doesn't change, perhaps because it's directly input here. But that doesn't matter. When I copy this number back to the MBC, and that will automatically just keep 1 decimal place. So the rest of the job is to copy all these number back. All right, I have done copying all these numbers back to MBC. So part B, assume that this firm stock closed at 77.56. So you can see that our estimate of the intrinsic value per share is actually lower than this. So that means we believe the stock is overvalued, right? How does your valuation estimate compare with this closing price? What do you believe are some reasons for the difference? First choice, stock prices are a function of many factors. This is true. It is impossible to speculate on the reasons for the difference. So this sentence is not true because even though stock price depends on many factors, but given that our estimate is lower than the actual price, and given that we know that where our estimate comes from, so we can still do some analysis for what's the reasons, what's the driving factors for their discrepancy, right? So then the second choice is our stock price estimate is lower than the ANF market price, indicating that we believe that ANF stock is overvalued. So far, so right. Stock prices are a function of expected NOPAT and NOA. This is true because NOPAT and NOA determine FCFF as well as the WACC discount rate. And this is also true because this is the discount rate in the discounted cash flow model. Our low stock price estimate might be due to more pessimistic forecasts, which means it's for the cash flow forecast or a higher discount rate compared with to other investors and analyst model assumptions. And this is also true because if our cash flow estimate is lower or our discount rate estimate is higher, both will generate a lower intrinsic value compared with other financial analysts. So this is true, but just to complete our analysis, let's just also read the other two choices to see why they are not true. Our stock price estimate is lower than NF market price. Actually, you can see that the third one, the large part of the third one is exactly the same as the second one. The difference comes from this sentence. Our lower stock price estimate might be due to more optimistic forecasts. So this is wrong because more optimistic forecast mean that our estimate should be higher, or a lower discount rate will mean the same thing. So this is not true. Our stock price estimate is lower than the ANF market price, indicating that we believe that ANF stock is undervalued. So this is not true because our intrinsic value is lower than the market price, so we should believe that the stock is overvalued. So now let's check our answer. All right.